In today's video, we are going to look at independent events. Now, we say that two events are independent if the outcome of one of the events has absolutely no impact on the outcome of the other. So, for example, if I had a coin and I wanted to toss it twice, then whatever I got on the first coin toss has absolutely no impact on what I got on the second coin toss. Or similarly, if I had a coin and a dice and I was to throw them at the same time, then what I got on the coin had absolutely no impact on what I got on the dice, and what I got on the dice had no impact on what I got on the coin. So we say that those two events are independent because they have no impact on the outcome of the other event. Now, we're going to be calculating the probabilities of independent events in this video, and I think the best way to do that is just to start off straight away with an example. So a question that you might get asked is, if I toss a coin and roll a dice at the same time, remember which are independent events, they have no impact on the other, then what is the probability of me getting a tail on the coin and a 4 on the dice? And we're going to work through this question, so you might want to copy this down. But what I need to do to work out the probability of getting a tail and a 4 is first of all work out what the probability of getting a tail on a coin toss is. So the probability of a tail on a dice, on a coin rather, well, there's only one side which is a tail, and there are two sides altogether, so the probability of me getting a tail is a half. And I also need to work out what the probability of me getting a 4 on a dice is. Well, there's only one side that has a 4 on it, and there are 6 sides altogether, so my probability of getting a 4 is 1 out of 6. Now, the way that we work out the probability of getting a tail and a 4 is by multiplying these two probabilities together. So if I wanted to find out the probability of a tail and a 4, so that and is really important there, tail and a 4, then I would need to do the probability of a tail, which is a half, multiplied by the probability of getting a 4, which is 1 out of 6. Now, when I multiply fractions like this, or probabilities, it's really easy because I can just multiply the top two numbers. So 1 times 1 is 1, and 2 times 6 is 12. I can just multiply the bottom numbers as well. So my probability of getting a tail and a 4 when I toss a coin and roll a dice is 1 out of 12. Now, it's probably important to get a generic formula written down here. So if you could copy this down, please, that would be great. Let's say A and B are independent events. So what that means is the probability of A happening, or if A happens, it has absolutely no impact on what happens with B. So A and B are independent events. And the probability of A and B happening equals the probability of A, whatever the probability of A is, multiplied by the probability of event B. And this here is a really important formula which you'll need for the rest of this video, and also the questions that you're going to get on today's worksheet as well. So if A and B are independent events, then probability of A and B happening is the probability of A multiplied by the probability of B. Now, if you need to pause the video to get this page copied down, or these 2 pages copied down, that's fine. In this video, we're going to do 2 more examples before you have a go at the worksheet yourself. Okay, now all I've got left for today's video is 2 more examples of finding the probabilities, or calculating the probabilities of independent events. And the first one I've put up here, which is that a bag contains 3 red counters, 4 blue counters and 2 green counters. And it says that I choose one counter at random, place it back into the bag, and then choose another counter. Now the important bit here is that after I choose the first counter, I place it back into the bag, which means that the probability or the probabilities for my second choice are exactly the same as the probabilities for my first choice. So what that means is the outcome of the first choice has absolutely no impact on the outcome of the second choice. So it means that these are independent events. Now the first thing that I'm going to do is work out the probability of selecting a red counter, a blue counter and a green counter from the bag. So the probability of a red, well, there are 3 reds in total out of 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 9 counters altogether. So the probability of selecting a red is 3 out of 9. The probability of selecting a blue will be 4 out of 9. And the probability of me selecting a green counter, well, there are 2 of them, so it'll be 2 out of 9. And we're going to use these in a second. So the first question asks, what is the probability that I selected 2 green counters? So what that means is I selected a green on the first choice and then a green on my second choice. Well, the probability of green is 2 out of 9. And I need to multiply that by the probability of getting a green again. So again, it would be 2 out of 9. Now I just mentioned that multiplying fractions is easy because we just have to times the top 2 numbers. So 2 times 2 is 4. And times the bottom 2 numbers, 9 times 9 is 81. So the probability of me getting 2 green counters is 4 out of 81. Now, a really similar question for blue counters. What's the probability of me getting 2 blue counters? Well, this time the probability of a blue is 4 out of 9. And I need to multiply that by the probability of getting a blue again. So again, 4 out of 9. So the probability of selecting 2 blue counters, 4 times 4 is 16. And 9 times 9 is 81. So the probability of me getting 2 blues is 16 out of 81. Okay, 3 and 4 are slightly different. Question 3 says, what is the probability of me getting a red counter and then a blue counter? So I want a red counter on my first go. Well, the probability of a red counter on my first go is 3 out of 9. And then a blue counter. So on my second go, the probability of me getting a blue counter is 4 out of 9. So I need to multiply these 2 probabilities together. 3 times 4 is 12. 9 times 9 is 81. So the probability of me getting a red and then a blue counter will be 12 out of 81. Really similar for question 4. I want the probability of getting a green counter and then a red counter. So a green counter on my first go is 2 out of 9. And I need to multiply that the probability of a red on my second choice, which is 3 out of 9. And then I multiply them together because they're independent events. So 2 times 3 is 6. And 9 times 9 is 81. So the probability of me getting a green and then a red is 6 out of 81. So that's it for example number 2. The final one that I'd like to, or the final example I'd like to talk through is this one here. And I want to talk about it because it says that a coin is tossed 3 times. Now, so far we've only dealt with 2 things that are happening, but now we've got that a coin is being tossed 3 times. And the question is, what is the probability that the coin lands on tails all 3 times? So what that means is I want a tail on my first coin toss, a tail on the second, and a tail on the third. So I want the probability of a tail and another tail and another tail as well. So a tail and then another tail and then another tail. So in order to do that, I'm going to need to work out what the probability of one tail is. And I know that that is a half because there's one tail, or one side with a tail on it, out of two sides altogether. So the probability of a tail is a half. Now, if I toss this coin 3 times, what I get on the first coin toss, the second and the third have no impact on one another. So they're independent events. So all I need to do here is a half multiplied by a half multiplied by a half. So that's a probability of a half on the first go, half on the second go, and a half on the third go as well. So multiplying 3 fractions is exactly the same. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the probability of me getting 3 tails if I toss the coin 3 times is 1 out of 8. Now that's the end of today's video with those 3 examples that we've done together. Your worksheet is on independent events, so in all of the questions you'll need to be multiplying probabilities together. And make sure that once you're finished with the worksheet, you take a photo of everything that you've done and upload it to Google Classroom so that your teacher can see what you've done today.